Hi everyone! In this video we're going to talk about angles, particularly how to classify angles in different types. Acute angles, right angles, obtuse angles, straight angles, reflex angles, complementary angles, supplementary angles, and congruent angles. So that's just a lot of definitions, and the calculations for these are not too scary. The calculations are fairly simple. They're basically just using the definitions and then maybe hitting the minus sign button on your calculator. And I've got a calculator up, as you can see, so that I can show you how to do these calculations, but I'm not even sure if it's necessary because the calculations are fairly simple for this topic. So basically there's the lesson. Our lesson is learning about those 5 different angle types. Well, the first half of the lesson anyway. So let's go through each of these. So let's define an acute angle. Now, acute angles are less than 90 degrees. So for instance, one that you guys should probably know is a 45 degree angle. So a 45 degree angle is sort of half of a right angle. And so it's sort of just eyeballing it. This looks roughly like I took a 90 degree, like a corner, and split it in half as 45 degrees. Right, another good one is, let's see if I can sketch it. That's about 60 degrees, right? Normally we'd have protractors and we'd sort of play with these in class for a little bit. A lot of you guys don't have protractors at home, but 30 degrees is sort of a third of a right angle, 45 degrees is half of a right angle, and 60 degrees is like 2/3 of a right angle. And those are all acute angles. Now, right angles, you guys all know. If you're in my class, you've probably heard me make the joke that if you're feeling cold, you should stand in the corner because it's always 90 degrees. I know, it's pretty funny, right? Yeah, so a 90 degree angle is a corner, a straight corner. And usually we use this symbol. And that symbol, that sort of square symbol, means that it's 90 degrees. Now, an obtuse angle is an angle that is more than 90 degrees. So let's say we do an angle like this. I'm going to ballpark that. Maybe it's 110 degrees-ish. Don't have a protractor. Let's call that 110. And that is an example of an obtuse angle. And those are the 3 angles that you're probably most familiar with labeling and using, and they're the ones that come up the most in everyday situations. But technically speaking, a straight line also has an angle in it. If you imagine like this point here, how much is going from here all the way around to here? So if you imagine this is like a door. You've got a door on one side, and you swing the door all the way from this left-hand side all the way across to the right-hand side. How much did you swing the door? You swung the door 180 degrees. And so 180 degrees is called a straight angle because it ends up pointing, if you rotate something 180 degrees, it ends up pointing the exact same direction that it started. I mean, maybe it switches from right to left so it can flip around, but it makes a straight line all the way across, which is why it's called a straight angle. And now this last one is one you probably learned in middle school, and you've probably never used since middle school because it's honestly not that often that we talk about or care about these things called reflex angles. But the idea of a reflex angle is if you've got like a full circle rotation is 360 degrees, right? So if I've got an acute angle on one side, let's draw 45 again. So let's say you've got 45 degrees on this side. But what if I don't care about the angle on this side? What if I care about the angle that goes all the way around the rest of the circle? Well, that is called a reflex angle. And a reflex angle is just like your full circle, your 360 degrees, not 060, 360 degrees, minus your acute angle, or obtuse angle, whatever you have. The angle on the other side gives you your reflex angle, in this case, 315 degrees. So it's more than straight, but less than a full circle. Okay, so anything that's more than straight or less than a full circle is a reflex angle. So there's one example. Another example really quick. Let's say we've got an angle like this. The angle on this side is acute. Or sorry, not acute. What am I saying? That's not an acute angle. That's an obtuse angle. So the angle on this side is obtuse, and the angle on the other side is reflex. So a reflex angle can either be across like the other side of an obtuse angle, or it can be the other side of a right angle, or it can be the other side of an acute angle. All right, now, normally I would do this in class. I would encourage you to go onto this Kahoot if you like, if you want to practice these definitions. You can just type that code into your computer or your phone or whatever, and you can play it on your own, or you can get together with your friends and have a Skype or Zoom Kahoot party if you like. It'll be good times for everyone. But I'm just going to jump right into doing some calculations with these things. Oops. So the next piece is the idea of complementary and supplementary angles. And these are actually really, really useful things. So often you've got a corner of a room where you've got like a corner of a bookcase or whatever, and you've got some piece that's splitting your right angle into two pieces. And on one side you'll have, say, in this case, your 65 degrees. Well, then how much is left to be on the other side? In this case, I've labeled it for you, it's 25. But that should make sense to you because there's a total of 90 degrees here. If I've got 90 degrees and I use up 65 degrees on one side, how much is left? Well, 90 minus 65, sure enough, is 25 degrees. So complementary angles are angles that add up to a 90 degree angle. So what angle is complementary to 25? Well, 25 is complementary to 65. And so then 65 is complementary to 25. Oh, didn't mean to switch colors, but whatever. So those two are complementary to each other. So what's complementary to 25? 65 degrees. What's complementary to 65? 25 degrees. Supplementary is the same thing, but in a straight angle. So we've got a straight angle here. A straight angle is just like a straight line, right? So this straight angle is 180 degrees. And so if we come in at 40 degrees on one side, what angle is on the other side? Well, I've labeled it here for you. It's 140. But we can actually calculate that as well because straight lines have 180 degrees in them. So if you've got angles that meet at a straight line, they're supplementary. And so 180 minus 40, 180 minus 40, sure enough, is 140 degrees. Okay, now let's just quick recap. Let's do our definitions. Which of these angles are acute, right, straight, whatever? So our straight angle was the 180 degrees. Our right angle was the 90 degrees, right? And that's sort of the setup for the question. We had 90 degrees here. That was 90 degrees. And we had a straight angle here, right? That whole thing here was a straight angle. Our obtuse angle was the 140 degrees. Our acute angles, we had several of them. The other ones were all acute. So our first question, we had 25 degrees, we had 65 degrees, and we had, I did it in orange, I guess, 40 degrees. Okay, let's try one without a diagram. What is the complement? Complement is just another way of saying what's the complementary angle of. What is the complement of 57 degrees? So complementary means we care about a right angle. Now, there's sort of a memory trick for this. So you notice that 90 degrees is half of 180. Well, if you notice that a C is 90 degrees for complementary. What if you take two C's and you stick them together? If you stick two C's and stick them together, you get 90 degrees times 2, which is 180 degrees, which is supplementary. So that's a memory trick. If you're having trouble remembering complementary versus supplementary, just think that a supplementary is literally two complementary angles stuck together to make an S, which stands for supplementary. Okay, so what is the complement of 57? 90 minus 57. And I'll show on the calculator. You may not need a calculator for subtraction, but if you do, that's fine. And you get 33 degrees. What is the supplement? What is the supplement of 115? So supplementary means 180 degrees. Take away, in this case, the obtuse angle. And what are you left with? 180 minus 115 equals 65 degrees. All right, now let's do some problem solving with diagrams. Solve for the missing angles. Okay, I'm going to be a little bit cheeky. I'm going to fill in this angle first. It says to solve for the missing angles. It doesn't say which ones to solve for. What angle is that? That's a straight angle. 180 degrees. Okay, but seriously, what this question is really trying to get at, though, presumably is this angle in here. Let's call it X. We have a straight angle here as well. That's 180 degrees. And we have 45 degrees on one side. So this is going to be our full 180 degrees, take away our 45 degrees, and that gives us our x. 180 minus 45 is 135 degrees. By the way, if you wanted, you could have also figured out this in terms of a full circle, right? So if you think of this as a full circle as 360 degrees, you could have done 360 minus the one supplementary angle of 180 minus the 45. And sure enough, you'd still get the same 135 degrees. So it doesn't matter if you think in terms of the full circle or if you just think in terms of the half circle. Either way, you're going to get the same answer. Okay, so let's not be cheeky on this one. Let's just solve for the one that they're probably sort of clearly looking at, is this one here. So y is complementary. Presumably that's a right angle. Looks like a right angle. We'll assume it's a right angle. So complementary to 12 degrees. So 90 degrees minus 12 degrees is 90 minus 12 is 78 degrees. If you wanted to, maybe you could figure out the reflex angle here. How would you figure out that reflex angle? Well, that reflex angle would be 360 degrees is the full circle minus the 90 degrees that we have for y, and that's 270 degrees. Just for fun, why not? Now this one, I warned my class. I deliberately did this not to scale, which is a bit mean considering the last one we needed to assume was 90 degrees. But it looks like 90 degrees, but it's actually going to turn out to be not 90 degrees. And let's go through and figure out exactly why that is. This thing here is a straight angle. How many degrees are in a straight angle? 180. And we're going to take away, I don't know if this is showing up clearly on the video, but this is 55 and 40. So take away 55 degrees, take away 40 degrees. And what are you left with? Well, in this case, I'm sort of skipping steps here, like just jumping right into solving it. Hopefully it should be clear to you that if you've got two pieces that are coming out of your half circle, you just need to subtract both of them to get your missing angle. Same thing with the complementary. Like if I had a complementary angle where I had an angle up here and I've got an angle up there and down here. Let's say this was 15 degrees and this was 20 degrees, and I've got x in the middle. Same thing. I would do my 90 degrees minus my one minus my other. So here I'm doing my 180 degrees minus my one minus my other. 180 minus the two angles that are taking up part of that straight angle gives us a total of 85 degrees. And 85 degrees looks close enough to 90, you can't necessarily tell, but it's not a 90 degree, not exactly. Okay, one more definition. Bisecting an angle is cutting an angle in half. It comes up a lot. Like often people want things to be symmetrical, and so you've got some shape, whatever, and you're carving wood or whatever, and you want to have some sort of support spar or whatever going along. Often you want to split the angle exactly in half, and splitting an angle exactly in half is called bisecting. And so all you do to bisect an angle, how do you divide something in two? You literally just divide it by 2. 20 divided by 2. Hopefully you don't need a calculator for that, but if you do, that's fine. 10 degrees. 88. What's bisecting 88 degrees? Well, divide by 2. 88 divided by 2 is 44 degrees. What's half of 35 degrees? Well, this one's going to give us a decimal because it's an odd number. So when we divide 35 by 2, we get 17.5 degrees. And last, what's half of 360? I don't need a calculator for this because a full circle is 360. Half of a full circle is a straight angle. So we actually know this one by definition. By definition, this is a straight angle, which is 180 degrees. Or divide by 2, and that's fine too. And now this last one. This one's just a little bit tricky. It doesn't come up that often. But if you know that your bisected angle is 33.5 degrees, what was the full angle? So let's draw this. So 33.5 degrees looks something like that. And that split some other angle in half. So the question is, if this split it in half, then this one's also 33.5 degrees, right? So you can think of this as 33.5 plus 33.5 degrees. Or you can think of it as double 33.5 degrees. And either way, you'll get the same answer. 2 times 33.5 is 67 degrees. Right, and that brings us to the practice. This one I thought was kind of fun. I found these dancing stick figures. Just try to label some angles. So I'll label one of each. An acute angle. I see that this angle inside his foot is an acute angle. I need some obtuse angles. So where's an obtuse angle? Inside his knee here. Oops, don't know why the pencil messed up, but that angle there is obtuse. And I need to label a reflex angle. Sure, so let's label a reflex angle here is more than straight. So more than straight makes that a reflex angle. Oh, what am I saying? R is right. Phew. My goodness. X is reflex. Reflex. So that's a reflex angle. A 90-degree angle looks like that's a 90-degree angle right there. His elbow. So I'm going to call that right. So there you go. So there's an example. I've labeled an acute angle and obtuse angle. R should be right angle, sorry. And X should be a reflex angle. So you can try practicing. In the dancing stick figures, there's lots of examples of each. Just trying to get you comfortable with using those definitions. Then there's a whole table here where you can fill out some complementary, supplementary, and bisected angles. Now, the trick for this, of course, an angle to its complement, right? You're going to do 90 degrees minus 90 degrees minus, your 35 degrees. But the same thing is also true backwards, right? 35 is complementary to whatever. Well, whatever is complementary to 35. They're complementary to each other. Same thing with supplementary angles. You get back and forth between these two using the same thing. 180 degrees minus, the one you know. And the bisected one we just practiced here. Moving from a bisected angle to a not bisected angle. How do you go from a bisected angle to a not bisected? You double it. Because bisecting is cutting in half. The opposite of cutting in half is doubling. By the way, I'd recommend you don't draw arrows all over your table like I did. Makes it a bit hard to fill out. Okay, and then there's a couple other examples underneath. This one here I like, by the way. Why is that not applicable? Well, you're going to have to figure out this angle, and then you can answer this question below. Okay, have fun with it. I love angles, and I hope you do too.